Okay, Yetam, welcome to your video tutorial revising area today. Hey, area is different from perimeter. The last few lessons we've been looking at the perimeter of certain shapes, okay? So here's this shape here, okay? If I was trying to find the perimeter, I want to know how long is it around the outside, okay? The area is different. Area is not asking us for the outside anymore. It's saying within this shape, what's all the stuff on the inside, okay? No longer around the outside. I want to know how much stuff is there on the inside. And this glorified stuff is square units, okay? The stuff on the inside is asking how many square units can fit within this boundary. What do I mean by square units? I mean literally a box that is 1 kilometer or centimeter or meter by 1 meter by 1 meter by 1 meter. How many of them can fit into there? Okay, that's why we always give measurements back as like 22 meters squared. That means 22 boxes that are 1 meter by 1 meter by 1 meter by 1 meter can fit within the boundary of something. Okay, that's what we're looking at with area. What you need to do is you will need to know all of these formulas. What I'd recommend is you pausing the video tutorial right now, drawing them down. As you draw each one, make sure you write the formula next to it because there's different formulas to work out different areas. Square, side by side. Okay, rectangle is length times breadth, okay? Length is one side, breadth is another side. So why didn't we say side times side this time? Well, that's because in a rectangle, I really hope that you should have got this from Sesame Street. You have two sides that are equal length, and then you have other two sides that are of equal length. But B, this side, does not equal that side, so we call them length and breadth. Okay, triangle, half base times height. Half of the base times the height. Okay, if you have a weird slopey triangle like you do here on this one, okay, it is the perpendicular height, always perpendicular. This triangle here, this little scalene looking number, again, always perpendicular. That is not the height, that is a side. Just like this one here is not a height, it is a side. Three big formulas. Rhombus, we didn't cover this one as well as we should have last year. The area is half of your diagonals. Your diagonals are called X and Y, okay? X and Y. Okay, your next shape is a parallelogram. Like hopefully most of you identified last lesson, it is the base, and again, it's the perpendicular height. Okay, this guy over here, he is not a height. He does not exist. He is simply a side. It's your perpendicular height or your height that goes up at 90 degrees, okay? Draw them down, formula. Trapezium is the hardest one. Okay, you might notice that these guys over here, unlike a parallelogram, aren't going in the same direction, so we don't have sides that are parallel, but we have a top and a bottom that are usually parallel. Okay, so instead we use the formula half of the height, half of the perpendicular height, okay, or half times height, of means times. Then we add that one and we add that one, okay? Half height, A plus B. All those formulas down, all those shapes with the formulas next to them is what you need. If you were asked to demonstrate that you have understood this concept, this is what you could be asked to do. Okay, example of a question is this triangle question, okay? And says find the area of the following shape. It's got a funny looking triangle. Numero uno thing to do is to check that our measurements are both in the same unit, both in meters, both in centimeters, okay? Don't mind what it is, that's the first thing that you do. If they are not, then you need to go back to your knowledge of converting units, okay, from our very first lesson in measurement, and you need to convert them to be the same type. Either convert them both to centimeters or convert them both to meters. So, we have a triangle that has a perpendicular height as indicated of 3.3 meters. Okay, and we have a base of 5. I know my area formula. I write that down first just in case I make a giant mistake, which I will because it will be a test and I will be nervous. Okay, make sure you write down your formula. Then I could give you a mark. No formula, no mark. Half of your base times the height. Then I sub into the formula, even in case I get a mistake on my calculator. Half of 5.8 times 3.3. Okay, and I probably should have told you decimal places, but that's okay, I didn't. 5.8 times 3.3 gives me an answer of 9.57. 9.57. That is not good enough. If you give me that answer in a test, I will give you 1 mark if it's out of 2. Okay, why? I'm no longer looking for the outside. Okay, I'm looking for the stuff on the inside. Okay. I'm saying I have 9.57 what? I have 9.57 little meter by meter squares inside that triangle. 9.57 meters squared. I need to identify that. If I just write 9.57, no deal. Okay, that's the answer. Sorry, let's have a look at a trickier shape. Okay, this one is a trapezium. Okay, I know my formula for a trapezium is area equals half of my height, A plus B. Okay, so if you look at your formula, that would be subbing in. My height is this guy here, 2 centimeters. Half times 2. Okay, A is 5, B is 3. B could be 5 and A could be 3. It really wouldn't matter. It's like saying 5 plus 3 and 3 plus 5. You get the same answer. Okay, so let's move from left to right. I can just plug this straight into my calculator, or I could be a little bit more tricky. What's 2 divided by half of 2? 1. I'm not an idiot. Okay, brackets 5 plus 3 is 8. You might notice that there's brackets here and something on the outside. Okay, what do brackets mean? Brackets always mean multiply. That is like saying 1 times 8. Okay, 1 times 8 is 8. Now, what didn't I do? And what didn't I tell you to do at the start of doing this question, which we should have checked? Were all of my measurements in the same type of unit? They were all in centimeters, which means my answer is not 8. I would get 1 mark out of 2 if I gave 8. I need to say 8 centimeters squared. And that's it, guys. That's area.